which we are going to compare the acidity of alkene, alkyne and alkane. First of all, we need to understand that what is acidity? What do you mean by acidic nature? So basically, acidic nature is shown by any compound which is having proton in it and has the tendency to lose that proton. As you can see here, the alkane, alkene and alkyne, all the three compounds is having proton in it, which is in the form of H+. Alright, so we need to understand that which of these compounds is having great tendency to release the proton, and that if you are able to find that compound which is having great tendency to lose this proton, that will be more acidic in nature. So first of all, we need to understand about the structure of these compounds. So here you can see this is the alkane molecule. Name of this alkane is ethane. This molecule is ethene, and this is what? Ethyne. So now we have to understand the ability of losing the proton. So for that understanding, we need to know about the concept which is known as hybridization. So as you know, the alkane have sp3 hybridization, alkene having sp2 hybridization, and alkyne is having sp hybridization. The carbon involved in these molecules have these hybridization, and this hybridization leads to a concept which you need to know, that here the involvement of S is around 50%. Alright, and P is also 50%. Here the involvement of these three orbitals, sp2 means one orbital of S and two orbital of P. So there are three orbitals involved in the formation of alkene molecule. So the if we divide the 100% into 3, so there will be approximately 33%, 33% and 33%. Same as these four orbitals. One is of S and 3 orbital of P. So we will having 25% of each orbital. Involvement of all the orbital will be 25%. So here clearly you can see that the involvement of S orbital is the highest in this alkyne molecule and the lowest in the alkane molecule, and in between this is the of alkene molecule. Alright, every bond is formed by 2 electrons, and if this carbon is having more S character, as you can see here, this carbon is having 50% character of S, so this carbon will pull these electron more strongly toward itself. So this proton can easily separate from this molecule in the form of H+ ion. Alright, and here you can see the involvement of S character is 20. So this carbon is having less tendency to attract these both the electron toward itself, having less tendency. So this proton will not can easily separate it from this alkane molecule. This applied to all the hydrogen atom involved in the formation of alkane molecule. So the two extreme case I had discussed, that alkane is having the least tendency to attract these both the electron, and alkyne has the greatest tendency to attract these electrons toward itself. So alkyne can easily release its proton as compared to alkane. So here you had already got the answer that alkyne is having the greatest tendency to release its proton. So the alkyne will be the more acidic as compared to alkene and then alkane. So here you can see the ball and stick representation also of all the three. This is the alkane molecule, this is alkene molecule, and this is alkyne molecule. Alkyne is a linear structure, alkene having 120 degree of angle in between all the atoms, all right, and alkane is a tetrahedral having 109.4 degree of angle in it. All right, so do imagine these molecules and understand the concept of hybridization also, that hybridization affect the nature of the molecule also. Here you can see hybridization is involved in the effect of acidity also. So this is all a look if we have all the three compounds of alkyne itself. So how you are going to answer about the acidic nature strength? So here also you need to apply the hybridization concept, but as you know, all the carbon is having sp hybridization. This carbon is also having sp hybridization, and this carbon is also having sp hybridization. Both the carbon which is involved in the formation of triple bond. So now the answer will hidden in the group which is attached here around the triple bond. So as you know, these alkyl groups showing the positive inductive effect, it gives electrons toward the molecule if the molecule needed the electron. Okay, so if we have that, as I had told you, that these two electrons forming this bond is attracted more toward these carbons, because these carbons are what? sp hybridized. Same here also will happen, that the electron involved in it will attract toward this carbon because these carbons are sp hybridized, and they here also the electrons involved in the formation of these bonds will attracted toward the triple bond because the carbon here is sp hybridized. So you can see, you can compare here that the methyl group is already a group which is donating, or what you can say releasing its electron more easily as compared to hydrogen. So the release of hydrogen will here, the release of hydrogen is easy from this group as compared to the group having alkyl group around the triple bond, because this CH3 is much more satisfying this carbon by donating more and more electrons from here. So this carbon will less attract these double bond, and the proton will have the less tendency to release from this molecule. Alright, so always remember, if there is an alkyl group or any group which is showing positive inductive effect, then the acidity will definitely get decreased. So the order will be what? This proton is much more acidic in nature as compared to this, and this is the least one. This question is given in your NCERT and the explanation is also given there. So do read NCERT. I'll always say that NCERT is a very good book and you need to read line by line it. So here this is all about my today's topic. Thank you so much.